Welcome to this tutorial on electrochemical cells. You're still on Best Science Brain tutorial channel page. Today we are looking at electrochemical cell. First of all, we have to define what is meant by electrochemical cell. An electrochemical cell is a device which converts chemical energy into electrical energy and vice versa due to spontaneous redox reactions occurring in it. So it's a device which converts chemical energy into electrical energy and vice versa due to redox reaction taking place inside it. So electrochemical cell is sometimes called a battery. Then there are two major types of electrochemical cell. We have the primary cell, we also have the secondary cell. Examples of primary cells include the galvanic cell, otherwise known as the voltaic cell, the Inclán cell, there are two kinds of it. You have the dry cell and the wet cell under the Inclán cell. We also have the Daniell cell. These are typical examples of primary cells. We also have the secondary cells. Under the secondary cells, we have cells like the lead acid accumulator used in automobiles. We also have the nickel ion alkaline battery, which uses potassium hydroxide as its electrolyte. So, having done this, what are the differences between primary and secondary cells? The primary cell and the secondary cell. Primary cell cannot be recharged after discharging. So when the primary cell has discharged, all of its voltage becomes dead, throw it away. Secondary cell can be recharged after they are finished discharging. Then number two difference is that primary cell is less durable. It doesn't last for long. This one, secondary cell, is more durable. Number three, primary cell has high internal resistance. This has low internal resistance. Another difference is primary cell supplies less current and voltage, while it supplies higher current or voltage. So these are the basic differences between primary cell and secondary cell, or the advantages of secondary cell over primary cell. Then what advantage of primary cell has over secondary cell? Primary cell is relatively cheaper compared to secondary cell. So having done that, now discuss the concept of a simple galvanic cell. A simple cell, galvanic cell, consists of, we have two containers. Inside these containers, we have metals placed in each of the containers, and then solutions of salts in them. This metal, assuming it's zinc, will be dipped inside a solution of its own salt. The metal here is dipped inside a solution of its own salt. For instance, we have zinc sulfate, aqueous here. Then this other metal, let's presume copper, is also dipped in the solution of its own salt, which can call copper sulfate. So we're trying to discuss the structure of a simple galvanic cell. Then these metals are joined by means of wire to each other. So this is the galvanometer, which indicates current flow, electron flow from anode to cathode, from copper strip, zinc strip to copper strip. Then we have a tube that joins the two containers. And then inside this tube, we have a gel or a liquid which is not a common salt. For instance, we have silver nitrate, we have potassium chloride, we have sodium sulfate as electrolyte inside this. So, what are the components of a simple electrochemical cell? The components include one, electrodes. So these metals, zinc strip and copper strip, are the electrodes. This electrode is called the anode, while this one is called the cathode. The anode is the electrode through which current enters the electrolyte. The liquid inside each container is called an electrolyte. Then the cathode is the electrode by which current leaves the electrolyte. So a simple cell has two electrodes, the anode and the cathode. Then when you have two metals serving as electrodes, electrodes are conductors to which current enter and leave electrolyte. How do we know which of the metals will function as the anode, which are will function as the cathode? We look at their positions in the activity series. The more reactive metal, or the metal that has a lesser electropotential, will become the anode. So zinc is more reactive than copper. So zinc is the anode, while copper, being less reactive, becomes the cathode. Then at the anode, oxidation occurs at the anode. Oxidation means loss of electrons. So electron flows out from zinc and move towards copper. So because excess electron coming from zinc will now give zinc negative convention. The anode is negative, while the cathode becomes positive with respect to the anode. So having discussed the electrode, the first component of a electrochemical cell, anode and cathode, which is generally called electrodes, that allow current to enter and leave the electrolyte. The next component we are seeing on the diagram on the screen is the electrolytes. The electrolytes here are these solutions. So in chemistry, electrolytes are solutions that conduct electricity by movement of ions. So these liquids in the container are called electrolytes. Electrolytes of these solutions. Either they are aqueous solutions or they can be molten substances. But in this instance, they are solutions. They conduct electricity by movement of ions. For instance, the zinc sulfate we are seeing there, we ionize into zinc 2 ion and SO4 ion. It is these ions that carry current in the solution. The copper sulfate also, we see on the other side, we break down into copper 2 ion and SO4, which conduct current inside this cell. Apart from the electrolytes, another component we see there is the salt bridge. The salt bridge. The salt bridge is a tube. Its function is to create ionic equilibrium. And also it helps to neutralize excess ions in both half cells. Then it also completes the circuit. So that's the salt bridge. It's not an empty tube. It will contain an electrolyte which is different from the ones in the two containers. That's the salt bridge. As we're going to go on to discuss how these ions perform their function. Okay, having done that, looking at the electrochemical cell again, we now ask ourselves the reactions. Each of these container is called a half cell. So this is called a half cell. The container with the solution and electrode in it is called a half cell. While this container with this solution and electrode in it is also called another half cell. So this place where you have the anode, I would say that oxidation occurs at the anode. So the anode, this container with the anode is called the oxidation half cell. Oxidation half cell. Or anodic half cell, let me give to this container. While this one is called a cathodic half cell, or you can still call it reduction half cell, because reduction occurs at the cathode. And what is reduction? Reduction is electron gain, oxidation is electron loss. Oxidation is electron loss, while reduction is electron gain. So each of this is a half cell, this is the half cell. This is also another half cell. Two of them making up a complete cell, or what we call electrochemical couple in chemistry. Okay, having understood the concept or the components of a electrochemical cell, we now look at the reactions occurring at the anode and at the cathode. At the anode, which is the oxidation half cell equation, at the anode, zinc, which is the anode, will lose electrons. So you say the oxidation is electron loss. We lose electron, and whenever an element loses electron, it becomes positively charged. So zinc loses 2 electrons to give you zinc 2 ion. They will transfer the electron by normal convention. When you have oxidation, the electron is transferred to the right hand side to show that electron is given out as a product as it comes out to the external wire. So when we carry the electron to this side, it turns to plus. So now I have zinc giving us zinc 2 ion plus 2 electrons. So this is the oxidation equation. Why is it called oxidation? The oxidation state of zinc as a neutral element is 0. Why the state of zinc here is 2. So oxidation, apart from seeing it as the loss of electron, can also be seen as the increase in oxidation number. So zinc increases from 0 to 2. That means zinc having oxidized, anode having oxidized. So what happens as the reaction goes on, the anode will continue to dissolve, will go into solution, bringing us zinc 2 ion. Okay, now going to the cathode. At the cathode, the electron flow from the anode to the cathode. The anode participates in the reaction by dissolving. Does the cathode participate? No. The cathode is just a medium to which electron will flow in. So what then get the electron is not the cathode, not the copper. Copper remains static, steady, without dissolving. The electrolyte in the reduction half cell electrolyte, which is copper sulfate, we ionize to bring out copper 2 ion and SO4. It is this copper 2 ion that will now gain electron, which is coming out from the anode to be reduced to ordinary copper. So you see the charge here, this is 2, this is plus, this is 2 times minus, adding the charge is 2 here, operation sign is plus, 2 times minus 1 is minus 2, so 2 minus 2 is 0, meaning this is neutral, 0 here. So copper will reduce, going from +2 to 0, that reduction equation. Okay, having understood the concept of the electrochemical cell, what of the salt bridge, the chemical in the salt bridge? For instance, silver, let's assume that we have silver nitrate in the salt bridge. Silver nitrate will split into silver ion and nitrate ion. And from what we discussed at the anode, where oxidation took place by zinc going into solution. Now, the anode or the oxidation house cell will have plenty of zinc ion inside it because ions are being produced from zinc metal. So to neutralize the zinc ion, the nitrate ion from the salt bridge, negative ion, will now move. The NO3 will now move to the anode, then giving us zinc nitrate, neutralizing the positive charge zinc produced. So if NO3 moves into this place, that means silver ion will move into the cathodic half cell or the reduction half cell. So how does that happen? Now let's go to what we discussed before. At the cathode, we have copper 2 ion from the electrolyte gaining electron, giving us copper. That means that silver ion will now go. We're going to have excess SO4 remaining here in the container since copper 2 is being removed from the solution. So the silver metallic ion will now go and join or combine with the silver ion and neutralize the excess negative charge SO4 produced in the cathode. Okay, having done that, we now introduce redox reaction. Redox reaction we mentioned before as a reaction that takes place in the electrical cell. But by definition, what does it mean? Redox reaction, this word is obtained from two words. I've read that for reduction and ox for oxidation. So it means reduction, oxidation, reaction, abbreviated as redox. So by definition, we say redox reaction is a reaction which involves transfer of electrons between substances. So that is redox reaction. So there are different ways of defining oxidation and different ways of defining reduction. Oxidation is electron loss, gain of oxygen, gain of highly electronic element, and loss of hydrogen, increase in oxidation number. Reduction, on the other hand, is gain of hydrogen or electropositive elements, loss of oxygen, decrease in oxidation number, and also gain of electrons. Okay, now our interest now will be on how to balance half cell equations. Half cell equations, as we described in the electrical cell, are the reactions occurring at each electrode, at the anode compartment and at the cathode compartment. For instance, we have this reaction, we have to balance it. Manganese 4 ion plus S giving us manganese 2 ion. This is a half cell equation. Then how to balance this equation? For us to balance a half cell equation, the first thing we have to do is to make sure that the atoms are balanced. We have one atom of manganese here, we have also one atom of manganese over there. So we have to balance the electrons. To balance the electrons, since we have one atom, first of all balance the atoms and then the electron comes next. Balance the electron, we add the charges on both sides. The charge here is 4. The charge here is S times minus 1. Then over charge here is 4 plus S times minus 1 equal to the charge over there is 2. So we now have 4 minus S2. Minus S becomes 2 minus 4, giving us minus 2. That means S becomes equal to 2 here to balance. So the value of S in this equation is 2. I repeat, the first step is make sure the atoms are balanced. When they are balanced, then you add the charges on both sides and equate. 4 here, S times the charge, the that S number of moles of electron. L times minus 1 here equal to 2 over there. Then you make S the subject. Taking another example of a half cell equation, we have oxide ion giving us oxygen molecule plus Se. We are told to balance this equation. To balance this equation, we have to first of all balance the atoms. To balance the atoms, oxygen is 2 atoms here and 1 atom. Oxygen here cannot be 2 because this is charge. You can't charge an atom. This is 1 atom, this is 2 atoms. So what do we do? What we do is we multiply, we make the oxygen equal. This is 2O2 minus, making the atoms equal first before we talk about the electron. 2 atoms of oxygen and then 2 atoms of over there. So having made the oxygen atoms equal, we now add the charges on both sides. Equate both charges, the charge on both sides. 2 times minus 2 for this equal to, this is a molecule. A molecule has charge of 0, it's neutral. Then this plate, this one will be S times charge is minus 1. We now have minus 4 equal to minus S. That means S is equal to 4, minus cancelling minus. So the value of S here is 4. That means the oxide ion lost 4 electrons become oxidized to oxygen molecule. Now we'll take a bigger example again, whereby we have MnO4, the manganese ion, plus hydrogen ion, then plus S most electron giving us manganese 2 ion plus water. We have to balance this half cell equation that involves reduction because of electron gain, that is reduction. So what do we do? We make sure that the atoms are balanced first. We say that manganese is 1 atom here, 1 atom there balanced. Hydrogen is 2 atoms this side, 1 not balanced. Oxygen is 4 atoms here, 1 here not balanced. So we have to balance the atoms first. We now say MnO4 negative plus S plus Se giving us manganese 2 ion. Let's start with oxygen. So oxygen is 4 here. We put 4 in front of water, giving us 4 atoms of oxygen. Then by putting 4 here, that makes oxygen 8 atoms. 4 times 2 is 8. We also put 8 in front of hydrogen. Having done that, we check again. Manganese is 1 atom and 1 there. Oxygen is 8 atoms. 4 times 2 is 8. Oxygen is 4 atoms. 4 times 1 is 4. So all the atoms are balanced. Don't make the mistake of going to the electron, the charge first. If not, you fail the equation. The first thing you have to do is to balance the electron. So we add the charges. We now have minus 1 here plus 8 times 1 over there plus S times minus 1 equal to 2. This one has no charge, it's a neutral molecule. So minus 1 plus 8 is 7. This gives you minus S equal to 2. Collecting like terms, minus n becomes 2 minus 7, which is minus 5. That means S is equal to 5. So the value here is 5. The equation is now balanced with 5 moles of electrons. So having done that, we are going to look at how we can now balance an ionic equation. How to balance an ionic equation. For instance, we are given MnO4, everything other ion, Cr2O7, dichromatic ion, dichromatic ion, plus, okay, we have to stop the class. Now we're going to continue in our next tutorial. In the next tutorial, we're going to look at how to balance ionic equation. Please subscribe to Best Science Brain, both on the channel and also search us on Facebook and follow us. We'll be glad you did. Thank you.